Alright, today is the lab 4, so we'll be doing the test on compaction. Compaction is a way of densifying a soil, and the other purposes of doing this lab is to decrease the compressibility of the soil. So when we'll be putting the effort on the soil, it decreases the compressibility of the soil, which means the volume of weights gets decreased and the volume of solids remains the same. It's also a means of reducing the permeability of the soil and also increasing the strength of the soil. And as we know, compaction is not an index property, it's an engineering property, so it's also a means of improving the engineering property of the soil. After doing the test, we'll come up with some graph like this, where we'll be plotting the moisture content on the x-axis and the dry unit weight on the y-axis. We have the volume of the soil, we'll be measuring the weight of soil. So based on that, we can find the dry unit weight, and we'll be plotting these data on y-axis and x-axis, and we'll come up with graphs which look something like this. So if you see in this graph, as we increase the moisture content, starting from left to right, my dry unit weight keeps on increasing till it reaches a point where the unit weight starts decreasing with further increase in the moisture content. So the optimum point where the density starts decreasing, the corresponding water content is the optimum moisture content, and the density which is relative to the optimum moisture content is the maximum dry unit weight. Okay, so in the compaction lab, we'll be performing 3 kinds of compaction tests: modified, standard, and reduced. The difference between these 3 kinds of tests is the compaction effort we put into the soil. So for the modified test, we'll be using 10 pounds hammer falling from 18 inches high, and we'll put the soil in 5 equal layers, and the number of blows to the soil is 25. Similarly, for the standard, we'll be using 5.5 pounds hammer falling from 12 inches high, and we'll compact the soil in 3 equal layers, and the number of blows is again 25. Similarly, for the reduced test, we'll be using again 5.5 pounds hammer falling from 12 inches high. We'll compact the soil in 3 equal layers, and the number of blows in this case is just 15. So as you can imagine, the density changes from modified to standard to reduced. So to start the lab, let us see the general equipments. This is the ram to extrude our sample from the mold. This is the compaction mold with base. This is the collar that we fit on the top. I have my sample of soil and water in a beaker, and the moisture cans. Okay, to start the lab, we'll start measuring about 3 kgs of soil in a ball, so which looks fine. Now, I'll take the weight of the mold with the base, 4.14 kg. The next thing to do is put around 2 to 3 inches of soil in this compaction mold. Thank you. Make sure you break these large lumps of soil. Okay, after you put 2 to 3 inches of soil in your compaction mold, the next thing to do is fit your collar. You can fit it by sharing and make sure it's tight. So as I told you before, we'll be putting the compaction effort, which can be done by the hammer. So since I'm showing you the standard compaction test, I'll be compacting this soil in 3 layers with 25 number of blow on each layer. Make sure your compaction is throughout the surface of the soil. So 1, 2, 3, 4, 3, 4, 25. So I have applied 25 number of blows to the first layer. Next thing to do is again fill this mold with 2 to 3 inches of soil on top of that layer. Then repeat the same process. Apply 25 number of blows to the new layer now. 1, 2, 3, 4, 5, 23, 24, 25. Now we are putting the last layer. Again 25 number of blows. 1, 2, 3, 4, 23, 24, 25. So I have compacted 3 layers of soil in this mold. The next thing to do is take this collar out. Now we have taken out the collar from the top. While compacting your soil, sometimes it may be the case where your soil might come towards the collar. So after removing the collar, you want to make sure you flush it to the top. Now the next thing to do is take the weight of this compacted soil with the mold, which is 5284 grams. Now we need to extrude the sample from this mold. So the next thing to do is to extrude your soil sample from the mold, which I can do it by the help of this ram. So I'll place my sample over the ram. Someone has to hold it from the top, and I'll crank the handle of the ram so that it pushes the soil up and extrude the soil. As you can see, the soil is slowly coming up. Now this is the extruded sample of soil which we compacted just now. The next thing to do is measure a moisture can, 11 grams. Put it on the table. Then take some sample from the middle of the soil. Put it in the moisture can that you measured just now. Put the soil back in the. Then measure the mass of the soil, 20 grams. And put it in oven for drying for 24 hours. Now since we have completed one trial, the next thing to do is take about 150 ml of water in a beaker and mix it. After you mix your soil with 150 ml of water, the next thing to do is again repeat the same test, put it in 3 layers with required number of blows, and you need to repeat this process until there are 2 successive reductions in the moist weight of the soil. So we took the mass of mold, weight of mold and moist soil. So now we can find the weight of moist soil by subtracting 2 minus 1. So this would be 5.28 minus 4.14. Okay? Then we have the moisture can number, we have the mass of moisture can, we have the mass of can plus moist soil. After 24 hours, you will be filling in this row number 8. So let's suppose any value is 17. Based on these values, you can find the moisture content and the dry density with this formula. You need to repeat the test until there are 2 successive reductions in the weight of the moist soil. So let's suppose if my value here is 1.5 gram, 5 kg or whatever, keep on doing that till there are 2 successive reductions. So next time it may be 1.4, 1.3. So you need to keep on doing the test till there are 2 successive reductions in the moist weight. So since we calculated the moisture content and dry unit weight, which is weight of soil over volume of soil, we can plot a graph which looks similar to this. So you plot moisture content on x-axis and dry unit weight on y-axis. So as you keep on plotting these points, your graph should look something like that. So which means as you increase the moisture content, the dry unit weight keeps on increasing till it reaches a point beyond which the dry unit weight goes on decreasing with further increasing moisture content. This is because as we go on increasing the moisture content, the soil is slowly changing from semi-solid or whatever form to the liquid form. So it should have the lower strength, which means the lower unit weight. As you can see, there is one line called the zero air void line, which means beyond this line there won't be any data points. And this is the line which corresponds to the maximum saturation or 100% saturation. So all the volume of voids is filled with volume of water.